Hey Algebra 2, today we're going to learn about something called a piecewise function. So an example of a piecewise function is this graph you're looking at. So you can see that here on the bottom, from kids ages 0 to almost 5, they get in for $0 or free. So you have to be careful. There is an open circle right there. So at this next one, I have a closed circle right here to an open circle. So this next part of the graph says, so if you are 5 to under 15, then you cost $25. And then here we have a closed circle, so if you are 15 years old and older, you cost $80 to get in. So this is an example of a piecewise function where we have different age groups costing different amounts of money to get in someplace. So ages 0 to under 5 is free. And if you are 5 to under 15, you cost, so I'm going to follow that back, $25. And then the last group is if you are 15 and older, you cost $80 to get in. So that is how we use the endpoints of the graph to determine an admission cost. So this is what a piecewise function would look like that we are going to work with. So the function is something for one set of values and something different for another set of values. So I have to figure what is f of negative 8. So negative 8 is my x value, and so right here you have to look at your parameters. And this says if x is smaller than 0, then use 2x. But if x is 0 or more, then you use 5. So I'm looking at negative 8 here. Negative 8 is smaller than 0, so that means that I use the 2x part of the equation. So f of x means you just take that value and you plug it in for x over here. So f of negative 8 equals 2 times negative 8. F of negative 8 equals 16. So this says when the x value is negative 8, the y value equals 16. The next one says find x of 7. All right, so when my x value is 7, so you come back here to your parameters. Is 7 smaller than 0? No. Is 7 bigger than 0? Yes. Then you use this equation. When my x value is 7, my y value equals 5. So this one looks a little bit weird, but this, when it just gives a number, we'll show you a graph later, but you're just going to get a horizontal line. Like this is what f of x equals 25 would look like. You're going to have a horizontal line going on. All right, here we have 3 different equations. We're still going to use the same numbers from above. F of negative 8 and f of 7. All right, so we want to know the value when x is negative 8. So you come over here. Is negative 8 smaller than 5? Yes, it is. So therefore, I use 2 minus x. Once again, that is the value that I'm going to sub in place of x. So f of negative 8 equals 2 minus 8. Minus minus turns into a plus. So f of negative 8 equals 10. That basically says when x is negative 8, y equals 10. Now I have 7. Is 7 smaller than 5? No. This is a compound inequality. This basically just says x is between 5 and 8 is what it really says. And so 7 happens to be between 5 and 8. So therefore, I'm going to use this equation, negative x squared. So f of 7 equals negative 7 squared. Order of operation says that you have to square the 7, and then you just keep that negative there, and you get negative 49. This turns out a little weird. Okay, we're gonna skip over that, but it's really basically just practice of doing those over and over again. We're gonna go to the back and we are going to graph something. So I have my function here, and we will use 6 if x is smaller than negative 2, and we're going to use 3x if x is bigger than or equal to negative 2. So what you want to do is you take whatever these values are here, and I'm going to call that the divide line. So over here on my graph, at negative 2, I'm really just going to sketch in a line, and this is my divide line. And this says if x is smaller than negative 2. So if x is smaller here on the left side of this line, and I'm going to label it to help myself out for a minute. So on this side of the line, you use the function f of x equals 6. But on the right side of the line, that says if x is bigger than negative 2 or equal to negative 2, then you will use 3x. So on this side, you have f of x equals 3x. So step number 1, you draw in your divide line. Step number 2, we are going to draw the left line. So this is the left line here. That is basically the equation y equals 6, because f of x and y, for our purposes, are basically the same thing. Y equals 6 is a horizontal line. So this says that x is less than negative 2. So because I have a less than symbol there, I'm going to use an open circle. So here at the 6, so on the divide line, I have an open circle, and then I'm going to draw an arrow to the left. So x equals 6 until you come to the divide line, and then it is less than that value. It's almost there. Now we're going to draw on the right line. And the right line is y equals 3x. I think the easiest thing to do would be to make a table of values. So whatever your divide line number is, and in this case it's negative 2, so I'm going to plug negative 2 in for x, and then any value on this side of the line, and I'm just going to go ahead and use 0. Alright, so if x equals negative 2, I have 3 times negative 2, which gets me negative 6. And if x is 0, I have 3 times 0, which is 0. Right here, I have a greater than or equal to sign, so that tells me that I'm going to use a closed circle. So I'm going to plot this point, negative 2, negative 6. So I'll always have what kind of looks to you like 2 points on the line, and then my next point here is at 0, 0. You should generally take a straight edge and connect the dots and extend the line to the right. So you can never have two functions, two values at the same time. So on your divide line, you should generally have one open circle and one closed circle. So at x equals negative 2, you would really use the closed circle, and the open circle just says it approaches it. I have to do my intercepts. So I have both an x-intercept and a y-intercept sometimes. So what is my x-intercept? Well, the x-intercept and the y-intercept are both, in this case, going to be 0, 0. I have a point at the origin. You have to state the domain and the range of your function. You got to remember the domain are your x values. What x values am I allowed to plug in to my functions? Well, you could plug in any value that you want basically because you don't have any fractions and you don't have any radicals. So if you can plug in any value that you want, we use this notation, and negative infinity to infinity is another way of saying all real numbers, which means that you can plug any number in for x that you want to. Your range are your y values. That's the answers that you get out of it, and that kind of measures your distance up and down. So I never ever get a value smaller than 6 out of it, because I don't have any points down here. And then from there, all the other values just keep getting bigger and bigger and bigger. Right here, all these values are 6, and that's kind of taken up with this line over here. So this range is -6 to infinity. Maybe in Algebra 1, you would have said y is greater than or equal to -6. So this is an interval notation way we're going to start doing it. This is another way of saying the same thing. Let's try another one. All right, so the first thing that we're going to do is we're going to put in the divide line. So the divide line is at 5, and my graph counted up by 2's, so I'm going to put a dashed line right there at 5. If x is less than or equal to 5, so on this side of the line, I have g of x equals 12 minus x, and if x is greater than 5, then I use x plus 2. So on this side of the line, you have this equation. This side of the line, you have this one. So on my 12 minus x one, I'm going to make a table of values. I'm always going to start with my divide line number. So my divide line number is 5, and then any number to the left of that. So I'm going to use 0. So 12 minus 5 is 7, and 12 minus 0 is 0. I have a bar below that, so that means that I get the closed circle here. So I have a point here at 5, 7, and 0, 0. Oh, how about 0, 12? My bad. I was like, that is not looking right. And 0, 12. And it goes up like that. The other one is x plus 2. Whatever your divide line number is, I always use that twice on both of them. And then I'm going to pick any value to the right of here. So I'm going to go out a little bit and I'm going to choose 8. So if x is 5, that gets me a 7. And if x is 8, that gets me a 10. This one has a greater than symbol, so that I'm going to use the open circle. So right here, I have a circle there, and I have a point at 8, 10. And so it looks like this. My x-intercepts are none. My y-intercept is right there at 0, 12. My domain is almost always all real numbers, negative infinity to infinity. My range never goes below this point right here. And you can see that my smallest value here is at 7, and then they're both going up. So my range is 7 to infinity. Thanks.